Hello students, topic 1.6 Coulomb's law. Coulomb's law is basically the law for the force between two charges. This law is slightly similar to the Newton's gravitation law. What is Newton's gravitation law? The attraction force between any two bodies in the universe is proportional to their product of their masses and inversely proportional to the square of the distance between them. Similarly, in Coulomb's law, the force between attractive force or repulsive force, so I tell you this force is either attractive or repulsive. Gravitational force is always attractive, but electric force is either attractive or repulsive according to the nature of charges. Force between 2-point charges. 2-point charges means very small charges, is proportional to product of magnitude of their charges and inversely proportional to square of the distance between them. So in gravitation we discuss about the mass, and here we discuss about charges. Force F is proportional to Q1 Q2 by R square. F is equals to K Q1 Q2 by R square, where K is a constant. Sometimes it is known as Coulomb's constant. Its value is 9×10⁹ unit. Now make subject K from here. R square multiply with F, so it is Fr square, divide by Q1 Q2. Now make unit F Newton, R meter square. Coulombs are 2 times, so Coulomb square. So its unit is Newton meter square per Coulomb square. By its unit we can make its dimensional formula. It's m1 L3 T minus 4 A minus 2. m1 L3 T minus 4 A minus 2. Value of K is equals to 1/4 pi epsilon 0. What is epsilon 0? Epsilon 0 is the permittivity of vacuum. Remember student, we are discussing the force between two charges in air or in vacuum, not in other bodies. Permittivity of vacuum. Its value is 8.854 10⁻⁻12. Relation between K and epsilon 0 are inverse, so their unit is also inverse. Coulomb square per Newton meter square, and its dimension formula has the same number but they are opposite. m minus 1 L minus 3 T4A2. Now substitute the value of K in equation of force. F is equals to 1 upon 4 pi epsilon 0 Q1 Q2 by R square. This is a scalar form of the force. Now let's discuss vector form of the force. Vector form is most important for the numericals when directions are required. Now consider a reference point. Take two charges, Q1 and Q2. Position vector of Q1 is R1. In position vector of Q2 is R2. Now, if Q1 and Q2 are like charges, means both are either positive or negative. So therefore, Q1, Q2 greater than 0. If both are positive, product is positive. Both are negative, product again positive, minus minus plus. In this case, we already studied the like charges repel each other. By the repulsion, the forces go far away from each other. Suppose this is a force F on charge 1 by charge 2. Similarly, this is a force on charge 2 by charge 1. Suppose force on charge Q1 by Q2 is F12 is equals to 1 upon 4 pi epsilon 0 Q1 Q2 divided by R12 square R12 caret. Here R12 is equals to R1 minus R2. Similarly, if we consider R21, this is R2 minus R1. To describe direction, we use R12 caret. That means R12 vector divided by its magnitude. Similarly, for R21, it is R21 divided by R21. We studied unit vector in chapter number 4, standard 11. Now, similarly, force on Q2 by Q1 is F21 is equals to 1 upon 4 pi epsilon naught Q1 Q2 divided by R21 square R21 caret. Remember, for like charges Q1 and Q2, the forces are outward direction. F12, F21. Forces are outward direction. F12, F21. And for unlike charges where product of them is less than 0, forces are attractive type, therefore they are in inward direction. F12, F21. In both these cases, F12 and F21 are opposite. Similarly, F21 and F12 are opposite with each other, and they are same in magnitude. F12 is equals to F21. So, ratio of forces between two charges by each other is 1:1, means Q2 force on a Q1 is similarly Q1 force on Q2. So this is a vector form of Coulomb's law. Let's see topic 1.7, forces between multiple charges. In topic 1.6 we discussed forces between two charges, and here we will discuss forces between multiple charges. Let's see. Consider a reference point O. Charges Q2 and Q3 are here. Their position vector with reference point O is R2 and R3 respectively. Consider one more charge Q1. Its position vector is R1. Now, suppose the force on Q1 by Q2 is this, and similarly force on Q1 by Q3 is this. Let's see. Direction of force is this, F12 and F13. By using parallelogram method, chapter 4, standard 11, take its parallel component. Now, head of the F13 is connected with the tail of F12. So, this is the direction of F1, total force F1. Now, see. This is the direction of F2. Its parallel component of F2. This is F3. Head of F3 and tail of F12 are combined. So this is the direction of F1. Total force on F1 is algebraic sum of F12 and F13. F12 is 1/4 pi epsilon naught Q1 Q2 divided by R12 square R12 caret plus 1/4 pi epsilon naught Q1 Q3 divided by R13 square R13 caret. Now 1/4 pi epsilon 0 common. So Q1 Q2 divided by R12 square R12 caret plus Q1 Q3 divided by R13 square R13 caret. Now, if we consider n charges, so force on F1 is these two terms has Q1 common. So again take it common. The force on a Q1 is common Q1. So it's Q2 divided by R12 square R12 caret plus Q3 R13 square R13 caret plus dot 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 Qn divided by R1n square R1n caret is equals to, now write down in summation form, sigma. Equation start from the 2 and end with n. We use denotation I. Instead of I, you can use J, Qi upon R. 1, 1, 1 is common. R1i square, R1i caret. So this is a topic 1.7, forces between multiple charges. Thank you for watching my video.